In today's lesson, we are going to talk about what it means to use a compiler, syntax and errors we will encounter, as well as a brief introduction to objects and how we use them. Alright, so first of all, we talked about this a little bit the first day, but we'll just kind of recap that a program must be translated into machine language before it can be executed. So when we type our code, we are typing it using a language, and the compiler is going to translate what we typed, our source code, into a machine language for the computer to use. Syntax is essentially the language definitions. So how we're going to put together our symbols, reserved words, identifiers, and so forth to make a valid program. It's quite possible that a program can be syntactically correct, but not necessarily logical. So think about it, how you could say a sentence that would be grammatically correct, but make zero sense. That's what happens here, or what can happen in Java. So this bottom line says that a program will always do what we tell it to do, not what we meant it to do. So sometimes we will find when we run our code, it does what we asked it to. However, what we asked it to do wasn't what we really meant, and we need to fix it. So there are several kinds of errors that we encounter. The first is what we call a compile error. And this is when there are syntax errors that prevent the code from even running. So if there are compile errors, an executable version of this program is not even created. So we saw the other day when we compiled that after compiling the code, the compiler created a .class and a .ctext file. Well, if your code can't compile, those additional files are not generated. We can also encounter what are called runtime errors. And this is when we try to do something that just breaks the program. An example of this is trying to divide by 0. And lastly, we can run into logic errors. And logic errors are when your program's going to run, but it will have an incorrect answer. So it didn't do what we meant for it to do. Now, when we create a program, the program development cycle is going to go like this. So first we'll edit, we'll save our program, we'll compile it. If we have errors, we have to fix them. Then we recompile, and we keep that process until finally our program compiles. When it compiles, woohoo, we're excited. We go ahead and we run our program and we evaluate the results. Sometimes we get what we want and we're happy. Other times we have errors and we have to fix them and start the process all over again. All right, so we're going to move into Chapter 2 topics, which are laying out the foundation for object-oriented programming. At the end of our lesson, you will feel comfortable with these properties, and we will talk about an object, attribute, method, and class, and we'll also touch on encapsulation, and then these topics are things that we will learn about second semester. All right, so let's first start by describing what an object is. And an object is something that we can interact with within a program. It provides a collection of services that we can tell it to perform for us. We are going to have methods that define these services and interact with our object. So essentially, we can think of it like a class represents a concept, and an object represents an embodiment of that class. And a class can be used to create multiple objects. Now on the surface, this sounds very abstract. So let's get into a more concrete example. A common example that we'll talk about in Java and in a lot of programming languages are bank accounts. And the reason why this is a good example is because we all understand what a bank account is. Even if we don't have a checking account ourselves, we understand the concept that a bank account has unique information about a specific client. We can do specific tasks to interact with this bank account, such as deposit and withdraw money. We can get information about the account, such as the balance. And we also keep this information protected because we don't want people to be able to just go into our bank accounts and take out money without our permission. So in this example, the class would be the bank account. This is the concept. Now we can see over here that we have multiple objects from the same class, and each of these objects which is considered the realization or the actual implementation of the concept. Each of these is represented with its own box per se. So we have John's account with his balance and Bill's account with his balance. Ooh, I want to be Bill's friend. Look at all that money. And then we have Mary's account with her balance. So these are 3 different objects of the bank account class. Now, one of the things that we'll talk about second semester is the idea of inheritance. And inheritance allows one class to be used to derive via another. So I could have a superclass called account, and then I could break this up into more specific types of bank accounts. So this just shows us some of the power behind object-oriented programming. It allows us to create an idea and then further develop that idea and then to create instances of that idea. So it makes us have a lot of power within our code. All right, so back to the objects that we're going to use. When we are using our objects, we have the object itself, and then we have methods that this object can call. So the other day we saw how to print, and we did this system.out. That is actually an object. And the system.out is calling a method, and the method that it called was the print line. And you'll notice that we use this dot notation. So the object is calling a method. And then we see that we have this parameter inside parentheses. Now, sometimes inside the parentheses, it will be empty. In this case, there is something that we want to have printed, and that's why it's in the double quotes. All right, we are going to stop here, and we will take a look at some code in class tomorrow, and then we will finish with the rest of the lesson tomorrow. I'm going to finish this video for those of you that are absent. However, those of you that are watching this for homework, you can stop here. Okay, so the print method is a method that we use to print to the screen. And there is print and there is println. And the big difference is that println has an enter button at the end, essentially, and print does not advance to the next line. So if we wanted to print multiple things on the same line, we could use multiple print statements. And when we use println statements, it is essentially hitting the enter key at the end of the line for us. All right, this concept of abstraction. Abstraction hides details from people that don't need to know them. It's kind of like a need-to-know basis. And we don't need to know all of the details to know how to use it. Okay, we don't have to need to know how it works to use it properly. So for example, println. We don't see the code for println. We don't know what is done on the background. We understand it's going to display on the screen, and that's all that we need to know in order to use it. All right, so every character string is an object in Java defined by the string class. Now again, notice this naming convention. Because it is a class, the first letter is capitalized. Every string is what we call a string literal, and it is delimited, meaning it begins and ends by double quotation marks. We can use the plus sign to concatenate or append strings to the end of the other. It can also be used to append a number to a string. Now, a string literal cannot be broken across 2 lines in a program. And these are all things that we will better understand as we work with strings in our code. So this plus sign can also be used for arithmetic. Now that can be confusing when the same symbol can be used to both add and concatenate. So this is a specific thing that we want to make sure we understand. The plus operator its performance depends on the type of information on which it operates. So if both operands are strings, or if one is a string and one is a number, it performs string concatenation. If both operands are numeric, then it adds them. And the reason why it works this way is because it doesn't make any sense to try to add a string to a number. Mathematically, that would not make sense. So if there is one or both of the operands, the pieces being added, are strings, it automatically does concatenation. And the plus operator is evaluated from left to right, just like math, and parentheses can be used to force the operation order. All right, last topic are escape sequences. So escape sequences are used to force the computer to print something that normally has a meaning. So for example, if we wanted to print the double quotes, well, if we tried to put that in our print statement, it wouldn't work. It would think we were closing off the string and then it would yell at us. However, we can use an escape sequence. And an escape sequence is a series of characters that represent a special character. They begin with a backslash, and it basically indicates a special character, indicates a character should be treated in a special way. So in this example below, if I wanted to print the word hello in double quotes, I would use the backslash first. And that tells the computer to ignore the quote, that it is not being used to end my string, but instead it is being used in a different way. There are many escape sequences. These are the ones that we will use the most, specifically the tab, the new line, the double quote, and then the backslash F. Those are the ones that I've used the most, and the ones that you're expected to know for your AP test. All right, that's it.